All right, let's dive in. Today, we're talking about one of the biggest puzzles in renewable energy. And more importantly, we're looking at a seriously powerful solution that could change the game for a cleaner, more reliable energy future. So let's get into it.
So here's the big question, right? This is the fundamental challenge we face with renewables. The sun and the wind, they're incredible sources of power, but they're just not always there when we need them. Experts have a name for it. They call it intermittency. And honestly, it's the number one problem we have to solve to get to a truly sustainable grid. You see, on their own, both solar and wind have a pretty obvious Achilles heel. Solar panels? Absolutely brilliant during the day. But what happens at night? Nothing. And wind turbines, well, they can often pick up the slack then. But what about those super calm, still days? If you rely on just one, you're going to have some major gaps in your power supply. But what if we stopped thinking about them as two separate options? What if, instead, we combine their strengths? This is where the whole idea of a hybrid system comes into play, creating a true power partnership. And this right here, this is the aha moment. It's so simple, but so brilliant. Solar power obviously peaks during the day. Wind, on the other hand, is often stronger and more consistent at night. So when you combine them, you start to smooth out those peaks and valleys, creating a much more consistent, reliable stream of energy 24/7. It's just a perfect synergy. Okay, so let's get specific. A solar-wind hybrid system is, well, it's exactly what it sounds like. It's a single integrated power system that harnesses both the sun and the wind. And the goal here isn't just to produce more power, it's to produce it more reliably than either one of them ever could on their own. And look, the benefits here are just huge. First and foremost, you get that stable energy supply, which is kind of the holy grail for renewables. But it also makes the whole system more efficient, it dramatically slashes our reliance on fossil fuels, and ultimately, it helps build a stronger, more resilient grid for all of us. So it all sounds great in theory, right? But how do you actually build one of these things? I mean, it's got to be complicated. Let's take a look at the blueprint for turning this idea into a reality. You might think, hey, just stick some panels next to a turbine, right? Well, not quite. This shows it's a really sophisticated process. It's not just about placing hardware. It's about integrating everything from the initial design and storage solutions to deep economic analysis, all to create a system that's totally optimized for performance. It really boils down to 4 key stages. First up is site assessment. You've got to analyze years of weather data to find the perfect spot. Then comes the technical design, which is all about picking the absolute best components. After that, it's optimization, using some seriously powerful computer models to squeeze out every drop of efficiency. And finally, once it's up and running, it's all about continuous monitoring to make sure it's performing perfectly. Now, there's one piece of this whole puzzle that is absolutely critical: energy storage. Batteries, usually big lithium-ion ones, they're the secret sauce. They soak up all the extra energy when it's super sunny or windy, and then they release it when things calm down. This is what guarantees that continuous flow of power. And with battery tech getting cheaper and better every single year, this part of the solution is only going to get more powerful. Okay, so we've seen the blueprint. We know how it works in theory. Now let's see what happens when you take this concept and you scale it up. Way, way up. We're talking from the drawing board to something truly massive in the real world. For this, we're heading over to the Kutch district of Gujarat in India. It's home to a project on a scale that is, well, it's almost hard to believe. This thing isn't just another power plant. It's a massive statement about the future of energy. 30,000 megawatts. Just let that number sink in for a second. That is the planned final capacity, which will make it by far the largest renewable energy park of its kind anywhere on the planet. So what does a number like 30,000 megawatts actually mean for people? Well, it means enough clean electricity to power 18 million homes. This isn't just local impact. We're talking city-scale, even nation-scale impact here. And of course, a project of this magnitude takes a staggering amount of investment. We're talking about an estimated $18 billion to turn this incredible vision into a reality. As you can imagine, a project this big is no solo act. It's a massive collaboration between several major energy players. And you can see here, each one is responsible for a huge chunk of the park's total capacity. It's just a gigantic, coordinated effort. So, let's pull all this together. When we look at the success of these hybrid systems, and especially these mega projects like the one in Gujarat, what does it all mean for the bigger picture, for our collective energy future? I think it really boils down to three key things. First, we get that enhanced reliability, a steady power supply day or night, which, again, is the holy grail. Second, it proves the economic viability, that clean energy isn't just good for the planet, it's smart money. And third, of course, is environmental sustainability. This is a giant leap forward in the fight against carbon emissions.
But, and this is a really important but, if we want true sustainability, we have to be honest and look at the entire picture. It's not just about the clean energy that comes out at the end. We have to consider the full life cycle, from the environmental cost of manufacturing to the resources we use and the impact on land.
Yeah, we have to account for every single step. What's the impact of actually building the turbines and the panels? How much land do these massive farms require? What raw materials are we pulling out of the earth to create them? Balancing all of these challenges is absolutely key to creating solutions that are sustainable from start to finish.
So there's no doubt that hybrid systems are solving that huge puzzle of energy intermittency. It's a massive step forward, which leaves us with the next big question, right? What's the next piece of the puzzle we need to find? Is it about scaling battery technology even further? Or maybe it's about developing smarter policies to speed up this transition. The future of our energy really depends on finding those answers.